Alright guys, welcome to the retest review number 6 tutorial. I'm going to work through every problem on your retest review number 6 so that you'll be successful on the retest itself. The first 4 questions, you're just multiplying polynomials together, and to do that, all you do is a method called distribution. If you know the mental way, great, but I'm actually going to show you distribution because it works for every problem. Number 1, I'm going to multiply this first term, 7x times the x in the second polynomial, and I get 7x squared. I multiply 7x times the second term, which is a 1. 7x times 1 is 7x. Now I multiply my second term times both of those terms. 2 times x gives me 2x, and 2 times positive 1 gives me plus 2. The only other thing you have to do after you've distributed is combine like terms. There are 7x and 2x. I combine them and I get 9x. And this is my final answer. Question number 2, it's a binomial times a trinomial, but the method is still the same. I multiply this first term times all 3 terms. X times x squared is x cubed. X times negative 4x is negative 4x squared. X times negative 3 is negative 3x. And now finally I have to multiply the second term, negative 4 times x squared, to get negative 4x squared. Negative 4 times negative 4 is a positive 16, and I have that x as well. And the last thing is this negative 4 times negative 3, which is a positive 12. The only other thing you have to do after you distribute is combine like terms. I have a negative 4x squared and a negative 4x squared. That makes, and I'm going to write my x cubed, negative 4x squared minus 4x squared is negative 8x squared. And then I have negative 3x and plus 16x, so that's a negative 3 plus 16 is positive 13x. And then finally I have the plus 12 on the end, and this, that is my final answer. Number 3 is the same way. I have a binomial times a binomial. I multiply the first term x times x to get x squared. X times negative 3 to get negative 3x. The second term, negative 9 times x, is negative 9x. And negative 9 times negative 3 is positive 27. And as always, the very last thing you do is combine like terms. I have a negative 3x and a negative 9x. That makes negative 12x. And my other terms, positive 27 and x squared, don't have any like terms, so I just rewrite them. Number 4 doesn't look like I can distribute, but I actually can, because when I have a binomial squared, it means the same thing as the binomial times itself. A very common mistake, and this is a mistake, do not write this, this is not correct. A mistake is that everyone thinks this is x squared minus 81. That is not correct. You have to first write them out as a binomial times a binomial and then distribute. Okay, so same as the one I did before, x times x gives me x squared. X times negative 9, negative 9x. My inside terms, negative 9 times x is negative 9x. And negative 9 times negative 9 is positive 81. And hopefully you're starting to see a pattern. I distribute, and now I combine like terms. I have negative 9x minus 9x, so when I combine them, I get negative 18x. And here's my final answer. Okay, so that was multiplying polynomials. Now let's do the exact opposite. I'm going to give you a polynomial and ask you for the factors. To factor polynomials, you should always think about your flowchart in your brain. And in your flowchart, we said that always the first step is to look for a GCF. And if there is one, we got to factor it out. Step 2, I have to ask myself, how many terms do I have? If there are 2 terms, I need to check for a dots. If there are 3, there are 2 options. Sometimes I can do it mentally, and sometimes I have to use blankety blank or blank blank. The mental is used only when the coefficient of x squared is a 1. That's the only time I can use mental. Every other time I'm going to have to use blankety blank. So let's keep this flowchart in our minds while we do these problems. Let's look at 5. So I look for a GCF, but there is none because in front of this x squared is a 1, and I can't pull a 1 out. I can pull a 1 out, but it's not a GCF that needs to be pulled out. So I ask, how many terms? Well, I see 1, 2, 3 terms. So this is either going to be a mental or a blank blank problem. Okay. Now, because the coefficient in front of x squared is 1, this is actually a mental problem. All I have to do is come up with 2 numbers that multiply to this last term and add to this middle term. And those are going to be the numbers that fill in the second spots in each of my binomials. So I think, and this is where I have to be pretty good at mental math, I need to come up with 2 numbers that multiply to negative 15. Well, the first thing that comes to mind is 5 and 3. Well, because the 15 is negative, one of those terms has to be negative in order to make a negative when I multiply. So then I look at my 2 and I see it's a negative 2. Well, that tells me the 5 has to be negative because negative 5 plus 3 is negative 2. So my 2 terms are negative 5 and plus 3, and that's all I have to do on this one. This is my final answer. Okay, number 6. I look for a GCF. I see a 2, a 1, and a negative 3. There is no GCF. So now I ask, how many terms are there? Well, I see 1, 2, 3 terms, and I don't have a coefficient in front of x squared that's a 1. I'm going to have to use blankety blank. So this is where I write my first term, 2x squared plus blank, and then my last term, minus 3. And if it helps you, off to the side, you can write what your sum needs to be and what your product needs to be. The sum always comes from this middle term, which is a positive x, so I need to add to a positive 1x. And the product comes from multiplying the first term times the last term. 2x squared times negative 3 is a negative 6x squared. So I need to come up with 2 numbers that multiply to negative 6 and add to 1. I'm thinking of 2 and 3, and to get that x squared when I multiply, I have to have 2x and 3x. Well, in order to get negative 6, one of them has to be negative, and it's going to be the 2 this time because negative 2 plus 3 gives me this positive 1 here. Negative 2 plus 3 is positive 1, and negative 2 times 3 is negative 6. So I have my 2 terms, a negative 2x and a 3x. It doesn't matter which one you put where as long as you factor out the correct GCF. All right. I've got the hard part done, filling in the 2 blanks. Now is where I group them together and pull out the GCF of both groups. In the first group, I see that both terms have an x in them, And I see that also I could pull out a 2 because both coefficients are 2. So I'm going to pull out a 2 and an x, and I'm left with x minus 1. In the second grouping, I see that both terms have a 3 in common. They don't have any x's in common, so I can't pull out an x, but I can pull out a positive 3, and I'm left with x minus 1. Notice these two terms inside of my parentheses are the same. If they're not, you did something wrong. That gives me one of my factors. One of my factors is x minus 1. My other factor comes from the outside of the parentheses, which is 2x plus 3. And there's my answer. Number 7. I look for a GCF. I see a 7, a 22, and a 3. Nothing's coming to mind. So I ask, how many terms are there? Well, I see 3 terms. So I ask, is it going to be a mental method or blank blank method? The coefficient in front of the x squared is not a 1. So unfortunately, this is a blank blank method. So I write my first term, 7x squared plus blank, and my last term. If it helps you, off to the side, you can write your sum, which comes from the middle term, negative 22x, and your product, which comes from multiplying the first term times the last term. 7x squared times 3 is 21x squared. So now I need to come up with those two terms that multiply to 21 and add to negative 22. I'm thinking 21x and 1x. 21 times 1 is 21, and they both have to be negative. Negative 21 times negative 1 is a positive 21, and if I added those together, I would get negative 22x. So I've found my two terms, negative 21x and negative 1x. Now comes the time where I group them together and see if I have a GCF. In the first group, I notice they both have an x, and they both have a factor of 7 in common. So I'm going to pull out a 7 and an x, which leaves me with x minus 3 in parentheses. My second grouping, I think of a GCF of 1 and 3. Nothing's coming to mind. But I do see that this first term is negative, and I never want that. So I'm actually going to pull out a negative 1. Not just a negative, but a negative 1. And that leaves me with x minus 3. Notice again how the inside of my parentheses is the same. That is one of my factors, x minus 3. And the outside is my other factor, 7x minus 1. There is my answer. Okay, number 8. I did this one in class, but I'm going to work it out again. Number 8 is very important because you have to look for GCF first, and this one only has 2 terms. Okay, GCF of 81 and 16. Nothing comes to mind. There is no GCF. So I see that in this one there are 2 terms. Well, I see from my flowchart that if there are 2 terms, I need to look and check if it's a dots problem, difference of 2 squares. It is a difference because it's subtraction, and these are both perfect squares. So my 2 factors, this really is a mental kind of problem because all you have to do to get this first term, 81x squared, is multiply 9x times 9x. And all you have to do to get this last term, negative 16, is multiply 4 times 4, 1 positive and 1 negative. Another way to say that is that I got these 9x's by taking the square root of 81, and I got the 4s by taking the square root of 16. So that is my final answer. No blank blank, no mental, no nothing. Well, it is kind of a mental problem, but it doesn't have 3 terms, it only had 2, so it was a difference of 2 squares. Okay, last one in this section on factoring is number 9. Step 1, I look for a GCF, 3, 12, and 36. Aha, I see that they all have a factor of 3 in common. They don't all have an x, so all I can do is pull out the 3, and I'm left with x squared plus 4x minus 12. Okay, so now the part inside the parentheses is the part that I'm going to have to factor mentally, and I can factor it mentally because the coefficient of this x squared is a 1. So all I have to do is come up with 2 numbers that multiply to negative 12 and add to 4. I'm thinking of 6 and 2. Now, in order to get negative 12 when I multiply, one of those has to be negative, and I'm looking at my positive 4. I see that it has to be the 2 that's negative. So, don't forget, when you write your final answer, you got to drop down that GCF of 3 and then write your 2 factors. And those 2 factors come from using these 2 numbers, 6 and negative 2, x plus 6 and x minus 2. That is my final answer. Okay, next section of questions says to solve the quadratic equations by factoring. In order to do that, on number 10, I need to get my quadratic in standard form. I need to have x squared, my x, and my number all in a good order, all set equal to 0. So the first step is, when you're solving by factoring, you gotta set your equation equal to 0. So I see that this x squared term is negative. I don't like that. I'm going to move it to the left, and I'm going to move the negative 8 to the left. When they move, they change signs. So I get x squared. The 6x doesn't move, so he stays positive, and the negative 8 moves, so he becomes positive. And now I have it set equal to 0. I'm done with that step. Step number 2 is to factor completely. So I look at my polynomial that's left over, x squared plus 6x plus 8, and I see that because x squared has a coefficient of 1, I can actually factor this one mentally. So I come up with 2 numbers that multiply to 8 and add to 6. I'm thinking of 4 and 2. Because the 8 is positive and the 6 is positive, both numbers are going to be positive for my factors. So my factors are x plus 4 and x plus 2. So step number 2 is done. I have factored completely. Last step is to set each factor equal to 0. So my first factor, x plus 4, I set it equal to 0 and solve, and I get x equals negative 4. There's one answer. My second factor, I set it equal to 0 and solve, and I get x equals negative 2. There's my other answer, and that's it. I'm done. Number 11. I'm going to use the same 3-step process here and check it off as I go. Step number 1, set number 11 equal to 0. So I'm going to have to move the 16x and the 12 both to the left, which makes them negative, which changes their sign, I should say. They both become negative in this case. Now I need to factor this part, this polynomial that's left over. I need to factor that completely. And I think back to my flowchart. I ask if there's a GCF, and there is one. Actually, no, excuse me. 3, 16, and 12. Those do not have a common factor, so I'm going to have to use blank blank. Wait, I kind of jumped steps there. I'm sorry. Let's go through our flowchart. Look for a GCF. 3, 16, and 12. They do not have a common factor. So the next step, I ask how many terms are there? I see 1, 2, 3 different terms. So the question is, do I do it mentally or by blank blank? Well, because the coefficient of x squared is a 3 and not a 1, I need to use blank blank. Here we go with blank blank. 3x squared plus blank minus 12. So if you need to, off to the side, write your sum and your product. Sum comes from the middle term, negative 16x. The product comes from multiplying 3x squared times negative 12, and I get negative 36x squared. So I need to come up with two things that multiply to negative 36 and add to negative 16. I'm thinking of, let's see, what am I thinking of? Let's see, there's 1 and 36, that won't work. 2 and 18, probably 2x and 18x. 36 is negative, so one of those numbers has to be negative, and I look at the sum, it's negative, so I know I'm going to have a negative 18x. So those are my two terms that I put in my blanks, 2x and negative 18x. Now I group them together. The first group has a GCF of just x, and I'm left with 3x plus 2. The second group has a GCF of, let's see, 6. And because both of them are negative, I want to pull out a negative 6. And I'm left with 3x plus 2. Notice that the factors inside the parentheses are the same. That's one of my factors. And the other factor comes from the outside, x minus 6. So step number 2 is done. They are all factored completely. And the last step is to set each factor equal to 0. So 3x plus 2 equals 0. I solve for x, I subtract 2, and I divide by 3. I'm running out of room here. 3x equals negative 2. That means x equals negative 2/3. There's one answer. And I set the other factor, x minus 6, equal to 0. And I get x equals positive 6. There's my other answer. Notice that when it says solve the quadratic equations by factoring, my answers are not factors, they are x values, two x values that when I plug them back in would make those quadratic equations true. Number 12. I'm going to go through that same three-step process again, and the first step is to set the equation equal to 0. So in order to do that on number 12, I need to move the 6x to the left, which makes it negative. And now I have it set equal to 0. Step 2 is to factor completely. Think back to your flowchart, look for a GCF first. And actually this one does have a GCF. It's 2, and because they both have an x in them, I'm also going to pull out an x in front. That leaves me with x minus 3. Okay, now I look at the polynomial that's left over in parentheses. It doesn't even have an exponent of 2. I can't factor this anymore. So step number 2 is done. It actually is factored completely. Last step is to set each factor equal to 0. So 2x equals 0. If I divide both sides by 2, 0 divided by 2 is 0. There's one answer. And the other factor, x minus 3, if I set it equal to 0, I get x equals positive 3. There's the other answer, and I'm done. Last one in solving by factoring is number 13. I'm going to erase this one just a little bit. All right. Number 13, I'm going to go through my same factoring process. I need to set the equation equal to 0. And in order to do that, I'm going to move the x, which was positive. If I move it to the left, it's going to become negative x. And I see that if I combine it with the positive x that's already there, they cancel each other out. If I move the 9, there's no other numbers to combine the negative 9 with, so I just rewrite 4x squared and my minus 9. And now step 1 is done. It's set equal to 0. Step number 2 is to factor completely. So I look for a GCF of 4 and 9. There is none. So how many terms does it have? 2 or 3? This one has 2 terms, so it's a dots problem. I love those because they're so easy and fast. All I do is think of the square root of 4x squared, and that's 2. So that goes in the first spot of both binomials that I'm writing. And the square root of 9 is 3. One is positive and one is negative. Step number 2 is actually done. It is factored completely. Step number 3 is to set each factor equal to 0. So I set 2x plus 3 equal to 0. And I get negative 3/2. There's one answer. Second factor, I set it equal to 0. Add 3 to both sides and divide by 2. I see that my other factor is positive 3/2. And I'm done. Notice how all 4 of these questions have x values as the answer. I am actually solving by factoring, and I can't stop by factoring. I have to set each factor equal to 0. Okay, last section of the retest review is solving using the quadratic formula. And in order to use the quadratic formula, you still have to have your equations set equal to 0. In number 14 and 15, I got lucky. They actually both are set equal to 0. So I can proceed. To use the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. In order to actually use the quadratic formula, I need to know what my a, b, and c values are. Well, if your quadratic equation is written in the proper form, it should be written ax squared plus bx plus c equals 0. A is the coefficient of x squared, and the coefficient of x squared on this one is a hiding 1. B is the coefficient of x, which I see here is a negative 6. And c is the number involved in the equation, which I see here is a positive 3. Once I have those values, I'm going to plug into the quadratic formula. Now, some people know the quadratic formula the way I just sang it, and some people replace the first part with x equals opposite of b, because that's really what it is. Notice that the quadratic formula has a negative b. That means whatever your b is, it's going to end up being opposite of it. Watch. X equals negative b, and because my b is negative, it's a negative negative. Well, what is a negative times negative? It's a positive. Okay, so x equals negative b is actually a positive 6 here. Another way that I like to control my negatives and how I plug in is I like to use parentheses for every letter in the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, 4ac, all over 2a. So I go plug in my b, which is negative 6. I plug in my a, which is 1, and my c, which is 3. Okay, and just like I was saying earlier, when I simplify this, because x equals opposite of b, negative negative 6 makes a positive 6, plus or minus the square root of, I need to calculate what the part underneath the square root is called. And this part underneath the square root, this is your discriminant. That's the vocab word for it. If I actually type that in my calculator, and if you could see me now, you would see I'm typing in my calculator, parentheses and all, -6 in parentheses squared, minus 4 times 1 times 3 in parentheses. All of that underneath the radical, underneath the square root, simplifies to positive 24. So on the bottom, 2 times 1 gives me 2. Now, if you got this far, I'd be really happy, except that you also need to see if you can simplify the square root of 24. I'm going to see if I can't get my calculator back here. Or not calculator, my highlighter. Where'd it go? Well, I'm sorry. Clearly there it is. Okay, hopefully it'll stay there. Stay. Okay, I'm not sure where, oh, there it goes. Okay, so I plugged all of this mess into my calculator, which is the discriminant, and I got 24. Well, now I need to see if I can simplify the square root of 24. So just off to the side somewhere, square root of 24, I need to do my factor tree. 6 times 4, 3 times 2, 2 times 2, and I circle my pairs. The pairs come out as 1, 2, and I'm left with 3 times 2 inside. So that whole green part there simplifies to 2 square roots of 6, but I still have all this other junk, 6 plus or minus 2 square roots of 6 over 2. So all I did from this step to this step was off to the side, I simplified the square root of 24 and got 2 square roots of 6 instead. The last thing I can do is look at this little triangle of numbers here. Is there a common factor? And there is. I can pull a 2 out of all of them. So I'm left with x equals 3 plus or minus the square root of 6. And 2 divided by 2 on bottom is just a 1, which I don't need to write. So my answer is 3 plus or minus the square root of 6. Okay, number 15, same thing. I already have it set equal to 0, so I plug into my formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So on this one, my a value again is 1. My b value is negative 7. My c value is positive 4. And now I just go plug in my formula. Negative b plus or minus square root of b squared minus 4a. And c goes in this one. Okay, now I'm going to simplify. X equals negative b, or x equals opposite of b. Negative times negative gives me positive 7. Plus or minus, now I'm going to calculate my discriminant. And if you could see me, you would see me typing in my calculator, parentheses, negative 7 squared, minus 4, parentheses, 1, parentheses, 4. And I see that that simplifies to the square root of, all that yellow part became 33. And that sits on top of 2 times 1, which is 2. All right, I need to see if I can simplify the square root of 33. So I go off to the side. And I think of the factors 11 times 3. Those are both prime numbers. I can't go any further. So I actually can't simplify this answer anymore. This is a perfect answer. Okay, we're down to the easy question. Number 16 says find the discriminants. Well, the discriminant is just the part that's underneath the square root, which we already calculated and simplified. If you wanted to work it out again because you weren't convinced that we have already found it, the discriminant is found by doing b squared minus 4ac. It's just the part underneath the square root. You don't take the square root of the discriminant. So number 14, the discriminant, number 14's discriminant was, it all simplified to this positive 24. And if I wanted to calculate that again, just to prove to you, my b in number 14 was negative 6. So I do negative 6 squared minus 4 times my a was 1, my c was 3. And negative 6 squared minus 4 times 1 times 3 is 24. So that is part of my answer. It also says, though, to state the type and number of solutions. Well, when you get a positive number, you're going to have two real solutions. The only time it's going to be one real solution is if your discriminant is 0. But there's my answer to part A. Number 15's discriminant, I calculate b squared minus 4ac. From number 15, my b was negative 7, my a was 1, my c was 4. I type that all into the calculator, or I look back and I see, hey, we got 33 as our discriminant. Negative 7 squared minus 4 times 1 times 4. I'm checking again. Yes, it is 33. So part of my answer is finding the discriminant, which I did. State the type and number of solutions because it's positive. I'm going to have two real solutions. The other possibility for the type and number of solutions is if you get a discriminant of 0. If your discriminant is 0, then you get one real solution. If your discriminant is negative, that's when you get your two imaginary solutions. So hopefully by me working through this retest review with you, you've become enlightened. If you have any other questions, I'd love to help you in tutorials. Otherwise, I will see you later.